starts now. Let's begin by examining the company CoreAIoT Technology Co., Ltd. The document number 202,318,918,935,218 appears to be a reference or identifier for this presentation. So, who are we talking about? CoreAIoT is positioned as a startup, but one that's already made significant waves. Their core focus is high-precision positioning, specifically leveraging BLE angle of arrival, AOA, technology. They're not just playing around. They were the first in China back in September 2019 to actually mass-produce and ship these BLE AOA locators. That's a pretty bold move, being the first out of the gate. Now, this wasn't an overnight success. The text mentions 3 years of heavy investment in R&D within the BLE AOA space. This suggests they didn't just copy-paste existing tech, they built their own expertise from the ground up. And what did they build? Independently developed array antennas and high-precision positioning algorithms. These aren't off-the-shelf components. They're claiming these are cutting-edge technologies now widely recognized. Currently, their efforts are concentrated on 2 main product lines. First, there's the established BLE AOA technology, branded as Core Location TM. Second, they've launched a newer line combining UWB and AOA, called Core Sensing UWB plus AOA. The idea here is clever synergy, using their AOA strengths with the distance measurement prowess of ultra-wideband to tackle the spatial needs of countless IoT devices. Think about it. Knowing where something is and how far away it is simultaneously opens up a whole new range of possibilities. Let's dig a bit deeper into their timeline and product evolution. As we saw, 2019 was pivotal. They didn't just deploy BLE AOA, they led the deployment in China, conducted comprehensive research, and achieved a full system implementation from scratch to operational within just 5 months. That's impressive speed and capability for a startup. They became the first high-tech enterprise in China to achieve both mass production and successful project implementation of BLE AOA. That distinction matters. It signals market leadership and proven technology. Fast forward to 2022. Building on that BLE AOA foundation, they launched products featuring UWB plus AOA modules. Why this combination? The text points to specific applications: anti-loss systems, tracking, vehicular use, and area-based location management. This hints at moving beyond simple indoor positioning to more complex scenarios requiring both precise direction and accurate distance. It's about solving real-world problems for a variety of devices and environments. Who's behind this tech? The slide shows a team of about 20 colleagues. Let's break down the roles. You've got the essential hardware folks, hardware engineers, embedded engineers, and production engineers. Then there's the brainpower, algorithm engineers, full-stack engineers, and a test engineer. Marketing is covered by 2 marketing engineers. And supporting the core functions are an R&D assistant and a supervisor team. What stands out is the balance. You see the technical depth needed for developing complex hardware and software, but also the operational structure with supervisors and dedicated marketing. This isn't just a bunch of coders in a garage. It's a structured, functional team aiming for efficiency and execution. The claim is a highly efficient team, which is always good to hear. This slide essentially serves as a summary or call to action, reiterating their key offerings. We see the BLE AOA technology under the Core Location brand, emphasizing its role in high-precision indoor positioning. Then there's the newer UWB AOA offering under the Core Sensing brand, highlighting its ability to provide spatial distance and direction perception. It's a clear statement of their current technological focus and value proposition. They're offering solutions for both precise location and understanding the spatial relationship between objects. Okay, let's get into the nitty-gritty of how BLE AOA works. The basic principle relies on 2 key elements: array antennas and high-precision direction-finding algorithms. Imagine a standard Bluetooth antenna versus an array antenna. The array antenna can pick up signals arriving from different directions slightly differently because the signal hits each part of the antenna array at slightly different times or phases. It's like having multiple ears listening to a sound source. The direction-finding algorithms then take this subtle difference in signal arrival across the antenna array and calculate the angle of arrival. Essentially, it tells you where the Bluetooth signal is coming from relative to the receiver. This is crucial for indoor positioning because it allows you to triangulate or trilaterate a device's position based on the angles measured from multiple receivers. The text notes it's widely used for indoor high-precision positioning in existing Bluetooth devices and smartphones. This means it leverages the ubiquitous Bluetooth infrastructure, making it potentially easier to deploy than systems requiring entirely new hardware. This slide contrasts different positioning modes. On the left, we see a typical setup for 2D positioning. This often involves multiple anchors, receivers, placed strategically. A device, The tag sends out signals, and the system calculates its position based on the time or angle of arrival at these multiple anchors. It's like figuring out where you are on a map by knowing your distance from several known landmarks. The right side shows a more complex setup, likely for 3D or 4D positioning. This implies adding more anchors or perhaps integrating other data sources like altitude or time synchronization for higher accuracy or tracking movement over time. The text mentions 4-lector-AIoT Edimension Positionen, which seems to be a garbled term possibly referring to 4D positioning or perhaps a specific configuration involving 4 readers or sensors. The key takeaway is that the complexity of the setup scales with the required precision and dimensionality of the positioning task. Here's a claim of significance. First, bleaoa positioning system in China. This positions CoreAIoT as pioneers in this specific market. They highlight providing high-precision location service through domestic hardware and software products. This suggests a complete, end-to-end solution rather than just selling components. The diagram illustrates the components of their system. You have the AOA locator, the receiver station, the AOA tag, the device being tracked, the location engine, the software doing the heavy lifting of calculation, configuration software, CCS, and a location API service for integration. This looks like a typical RTLS, real-time locating system, architecture. The partner section indicates they offer this system to other companies, suggesting a B2B model. The inclusion of Bindi Shenzhen, local upgrade, might refer to the configuration software allowing updates without needing constant network access. This comprehensive offering is what makes them a complete solution provider. This slide shows a network topology diagram. It depicts how the positioning system is deployed in a physical space. You typically see the AOA locators, the receivers, distributed around the area to be covered. These could be mounted on walls, ceilings, or integrated into existing structures. The tags, worn by people or attached to assets, transmit BLE signals. The locators receive these signals, measure the angle of arrival, and send this data back to a central processing unit or cloud service. This central unit then calculates the positions and makes them available via the API. The diagram visually represents the flow of information from the physical world, tags and locators, to the digital world, location data. Now for a concrete example of their technology in action, a 5G fully connected intelligent manufacturing factory. This is interesting because it combines their AOA tech with 5G. The application is in the intelligent warehousing business of XX Group's kitchen and hot business unit. They're touting this as the first application of 5G and AOA fusion localization globally in smart factory operations. That's a big claim, suggesting they're pushing the boundaries of what's possible. How does it work? Forklifts in the finished goods warehouse transmit their location information via AOA. This info is sent accurately to the warehousing system and linked with physical inventory information. The result? Sub-meter level accuracy in positioning. And the benefits are tangible. Shipment loading efficiency increased by 50% and effective reduction in warehousing costs. That's a compelling ROI story. The quote from the factory manager adds credibility to these claims. Let's switch gears to a more consumer-facing application, an indoor playground for kids. The focus here is on safety. The system provides precise, real-time positioning of children. This enables safety alerts, presumably if a child wanders too far or enters a restricted zone. The goal is to allow parents and children to play freely while ensuring safety. The tagline, "Relax and let the parents enjoy their time with their children," captures the emotional benefit. This is a classic use case for RTLS, transforming anxiety into peace of mind for parents in potentially crowded or complex environments like amusement parks. Another everyday application, indoor navigation. This leverages bleaoa plus mobile phone positioning technology. Think about large venues like airports, shopping malls, or museums where GPS simply doesn't work well indoors. By deploying AOA locators throughout the building, a user's smartphone can determine its precise location. This allows for turn-by-turn directions, finding specific points of interest, or even guiding users to available charging stations or restrooms. The images likely show examples of such interfaces, guiding users through complex spaces. This application turns the challenge of indoor wayfinding into a seamless experience. This slide appears to be a placeholder or a transition, possibly indicating a section break or a visual separator in the original presentation. It doesn't contain specific technical content, but likely serves to organize the flow of information. Who are CoreAIoT's customers and partners? This slide showcases a diverse list of names. You see established players like Hikvision, a major security and surveillance company, and AVIC, part of the China Aviation Industry Corporation, suggesting applications in critical infrastructure. There are also prominent cultural institutions, like the Yiheng.Yue Museum and the National Library of China, indicating use in heritage and public service contexts. Retail is represented by Mayland, and presumably others. This breadth of partners suggests their technology is versatile enough to meet the needs of various industries, from security and manufacturing to cultural preservation and retail. Let's look at some specific partner applications, starting with smart supervision, 智慧监管. The example given is a detention center in Guangdong. The project requirements were clear: personnel refinement management and safety management. In a 3,000 square meter facility, the system achieved precise personnel positioning, cross-regional alerts, dynamic and static electronic fence alarms, electronic roll call, and abnormal alerts. This highlights the use of AOA for security, control, and accountability in sensitive environments. Next, smart data center. Again, the requirement is personnel refinement management and safety. In a larger 10,000 square meter data center, the system provided precise positioning within 1 meter, cross-departmental alerts, electronic fence alarms, electronic attendance, and intelligent inspection. This shows the application extends to managing personnel in critical IT infrastructure, ensuring safety and operational efficiency. Continuing with partner applications, we have smart hospital deployment in a VIP ward in Shanghai. Here, the needs were patient positioning management and real-time management of medical equipment. In a roughly 3,000 square meter area, the system enabled real-time viewing of patient locations and precise management of important medical equipment, achieving positioning accuracy within 1 meter. This is crucial for patient safety and efficient resource management in healthcare settings. Then, smart safety production in a shipbuilding factory in Xiamen. The requirements were personnel operation safety positioning and refined employee management. Over a 5,000 square meter area, the system achieved real-time safety positioning with 1 meter accuracy, reaching 0.3 meters in key areas. It also implemented electronic fence warnings for personnel safety. This demonstrates the technology's role in enhancing workplace safety in hazardous industrial environments. This slide seems to be another placeholder or visual divider, likely separating different sections or topics within the presentation. We're back to the core message and branding. This slide reiterates the two main product lines: bleaoa under the Core Location brand for high-precision indoor positioning, and the newer uwbaoa under the Core Sensing brand, focusing on spatial distance and direction perception. It's a concise reminder of their dual-track strategy, leveraging existing Bluetooth infrastructure, while innovating with UWB for enhanced capabilities. Now, let's shift focus to the second major product line, UWB plus omnidirectional AOA. The key here is the combination of ultra-wideband, UWB, and angle of arrival, AOA. UWB is known for its high-precision ranging capabilities, measuring distances very accurately. Omnidirectional AOA, in this context, likely refers to the ability to determine the direction of arrival using a compact antenna array, even if the tag isn't necessarily transmitting in a directional beam. The result is a technology that enables accurate localization between devices, specifically mentioning robots, luggage, and gates. This suggests applications in logistics, robotics, and access control. The claim is that it's widely applicable for high-precision positioning, building on the strengths of both UWB, distance, and AOA, direction. What makes this UWB plus AOA module attractive? The slide highlights two key features: small size and ease of use. It mentions a small size array antenna, suitable for massive IoT intelligent devices. This is crucial for scalability. If the hardware is bulky and complex, it limits adoption. Making it small and easy to integrate into a wide range of devices is key for mass deployment in the IoT era. The image shows a small, coin-sized module. The dimensions are specified: 5 cm by 5 cm, and 1.8 mm thick. That's incredibly compact. The weight is listed as 50 grams. This compactness and low weight make it feasible for embedding into everything from wearables to robots to smart luggage tags. The emphasis on easy to use suggests a simplified integration process, perhaps with pre-built modules or optimized firmware. How does this UWB plus AOA module perform its magic? The slide describes it as having an omnidirectional AOA plus distance and direction finding algorithm. It's characterized as a high-precision positioning algorithm that is built-in module, deep simplification, and optimization without external computing unit. This is a significant advantage. It means the complex calculations for determining both distance, using UWB time of flight or similar methods, and direction, using AOA, happen within the module itself. This offloads processing from the host device, making the system simpler and more efficient. The result is straightforward data output, likely via UART serial communication. Let's look at the performance specs. Range: indoor up to 20 meters. Outdoor open space over 100 meters. Accuracy: sub-meter level. Delay time: less than 1 second. Power consumption: very low, with average operating current less than or equal to 1 mA for both anchor and tag. This low power consumption is critical for battery-powered tags and anchors. Anti-interference. Features include anti-multipath algorithms and optimization for body and wall shielding. This addresses common challenges in real-world environments where signals bounce off surfaces or are blocked by obstacles. Ease of use, confirmed again with the built-in algorithm engine and UART output. Portability, reiterated with the small dimensions, 5.6mm x 5.6mm x 1.8mm, and lightweight, 50 grams. Additional features, built-in alarm threshold, allowing users to set safety distances for alerts or alarms. This makes it adaptable for different use cases. The bottom section lists the company details, Shenzhen CoreAIoT Technology Co., Ltd., with addresses in Shenzhen, Beijing, Shanghai, Qingdao, and Chengdu. The tagline, 国内第一家量产出货蓝牙 AOA 高精度定位基站厂家, translates to domestic Nobi manufacturer for mass production and shipment of Bluetooth AOA high-precision positioning base stations, reinforcing their market position. Now, let's explore a specific application, machine follow solution based on UWB plus AOA technology. The Internet of Things has a demand for device following or robot following scenarios. Traditional approaches might use visual solutions, like cameras. Visual solutions can be convenient as they don't always require extensive infrastructure deployment. However, they have limitations. Obstacles can block the view, lighting conditions can affect performance, and there can be blind spots. Visual solutions are also easily fooled by reflections or occlusions. The proposed UWB plus AOA solution offers a more robust alternative. It involves individuals wearing UWB plus AOA modules and the robot also being equipped with these modules. The robot can then determine the direction of the individual relative to itself using AOA and the distance using UWB. This information is fed into the robot's intelligent following processor, which adjusts the motion control unit to keep the robot following the person. This approach is less susceptible to visual obstructions and provides reliable spatial awareness for the robot. This slide likely contains a visual representation of the machine follow solution in action. While the image isn't described in the text, we can infer it shows a scenario where a robot is actively following a person. The robot would have its UWB plus AOA module constantly scanning for the signal from the person's tag. Based on the calculated distance and direction, the robot adjusts its path to maintain a safe and consistent distance behind the person. This kind of application is becoming increasingly relevant in logistics, elderly care, and potentially even personal assistance robotics. Let's consider a specific application, car key positioning, traditionally done using UWB time of flight, TOF, or time difference of arrival, TDOA. The common approach involves installing multiple anchors, typically 4 or more, around the car. The car key transmits a UWB signal, and the system measures the time it takes for the signal to reach each anchor. By knowing the speed of light and the time difference, it can triangulate the key's position. This works, but requires multiple hardware components around the vehicle. CoreAIoT proposes a different idea using their UWB plus AOA approach. Instead of multiple anchors, they suggest a single device installed in the vehicle. This single device somehow determines the position of the key. The exact mechanism isn't fully detailed here, but it implies the car's single UWB plus AOA module can effectively pinpoint the key's location relative to the car, possibly using AOA to determine the direction and TOF for distance, even with just one receiver. This could simplify the system, reducing the number of components needed inside the car. This slide likely shows a visual comparison or illustration of the two car key positioning ideas. On one side, you might see the traditional multi-anchor setup around the car, highlighting the complexity and number of parts. On the other, you'd see the proposed single device and vehicle approach using UWB plus AOA. The implication is that the latter offers a more streamlined, cost-effective, and potentially more reliable solution for locating a car key, especially in environments where signal reflections might confuse multi-anchor TDOA systems. This slide showcases a variety of potential applications for their positioning technology, moving beyond the specific examples discussed earlier. We see icons representing amusement parks, camping, pets, malls, and going abroad. This suggests a broad consumer appeal. In amusement parks, it's about finding lost children or parents. At campsites, it could help locate tents or equipment. For pets, it's obvious anti-loss tracking. In malls, it aids shoppers in finding stores or services. And for travelers going abroad, it could help locate luggage or navigate unfamiliar airports. This wide range indicates the versatility of the underlying AOA and UWB plus AOA technologies across different scenarios where knowing location is valuable. This slide appears to be a final visual element, perhaps a logo or a concluding graphic, reinforcing the brand identity of CoreAIoT. It serves as a visual anchor for the presentation. Finally, we arrive at the contact information. This is the Strategic Cooperation Expansion Director, Mr. Yiheng. His contact details are provided, Phone number 0755-2641-7586, email Yiheng.Yue at coreaiot.com, and the company website www.bleaoa.xyz. This is the standard Get in Touch slide, inviting potential partners or clients to reach out for collaboration or inquiries. The company name and addresses in Shenzhen, Beijing, Shanghai, and Qingdao are reiterated for clarity.